done actually back in May of 2015. So it was a month after I first got into this, when I was kind of considering all of it and going, well, I wonder how that would work. And so I created a little animation in Poser, created a point light with a limited throw ratio, so the light is limited as far as how far it'll go, and just animated it in a circle over the circular flat Earth map. Now, let me just say, neither one of these are to scale. I was just going for the concept here. According to Zetetic Astronomy and other resources, people looking at the sun and gauging its size and distance using a sextant, apparently the sun would be just shy of about 40 miles across and roughly 3,000 miles high. So obviously that's not being depicted here. That scale's not accurate, and it would go in and out on the various tropics and of course the equator. For more information on that, see my animation to the right there. It says how the four seasons work on the flat Earth model. Check that one out, and also you might want to listen to the radio show that I did with Zen Garcia, who's done some amazing work in tying all this into the Book of Enoch and how Enoch describes the various motions of the heavenly luminaries. Lots of good stuff there. But of course, the critics look at this and they say stuff like,
if the sun and moon were just circling over the flat Earth and getting too far away to see, then we would see them shrink and fade out of view as they set. But we don't. Flat Earthers will show you videos where the sun appears to grow or shrink, but this is an illusion due to thick clouds. You can always see that there are clouds near the horizon when they try to show this. Normally, this illusion does not happen.
oh, so he said that flat earthers are always hiding it behind clouds or whatever. Well, there's plenty of footage out there you can find where there's no clouds involved. This is from a really good video online you guys need to check out called Flat Earth Proof Sunset Off Pucket. I'm not sure if that's exactly how you pronounce it. Puket. Really interesting, showing sunset up. I believe this was actually somewhere off the equator. Again, you'd have to watch that video for yourself, but it clearly shows the sun changing in diameter as it goes away. So please take note not to ignore this evidence. Other videos you've seen where it looks like it's going in an arc like that and going off into the distance. Other videos where people have taken and used filters and whatnot and analyzed the sun moving and then done measurement of pixels across the screen, showing that it does in fact look like it gets a little bit smaller in some cases. In some cases it gets a lot smaller. In this case from 302 pixels to 290. And then of course there's this video right here, which apparently was shot in the desert, where there's going to be a lot less moisture, and so whenever there's less moisture you're going to obviously have less refraction and magnification.
You don't get to pick the anomalies that seem to agree with your views and ignore the common observations that don't, and still call yourself an honest investigator. That is intellectually dishonest.
So thinking about all this and thinking about what I had just shown you regarding atmospheric lensing, magnification, refraction, all that with regard to cities and objects at a distance on the land, I got to thinking, I wonder how this would work with the sun and moon. So this is what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification it does what we might expect it would. It gets smaller as it goes away from us. Alright, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface as it was moving parallel, the same height, the whole way over a flat surface. The refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so, even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Of course, again, depending on how much moisture is in the air, we could see that the sun doesn't appear to change in size at all as it goes down. We could see sometimes perhaps that it looks like it's getting bigger when it goes down. You ever see like a really big sunset or moonrise, moonset, where one of them looks really large on the horizon? Well, that could be because there's lots of moisture in the air causing that effect. Or when there's less moisture in the air, obviously you won't have as much magnification taking place, and so it looks smaller as it goes away. So it's all relative to the amount of moisture that's in the air. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if RobSkiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about. Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe.